they'll standardize it maybe. Yeah, that's really really interesting. So we can move ahead. What are the applications of it currently available, or maybe what's being worked on? But we want to discuss what are the applications that some people are currently working on. And is it open source? Is there any open source we can build quantum computer applications? Maybe if they are applications, if I may call it.
Yes. Yeah.
What
So I'll start with the open source, and then I'll go to different commercial applications. So from an open source standpoint, we have open source our ILL Neutrino language that essentially allows you to build quantum applications on top of it. So we have a compiler, we have a virtual machine, and then we also have a server. And so you can set up a server. The servers automatically connect and sync to each other. So it'll be really easy to create a distributed system. And the servers also have artificial intelligence inferencing, for example, and training embedded within that server. And so it's already set up for you to be able to scale artificial intelligence applications and make the most of the quantum mechanics that are ingrained within that particular system and network. As far as other different languages, you also could use Qiskit once again. But with Qiskit, like we discussed, you are limited to a total number of 24 qubits. With our custom language, you could extend upon that to your heart's desire. So there are no limitations. You could add libraries and you could add modules to it and really customize it to meet your organization's needs and your application's use case. As far as different commercial applications, our organization on our infinite internet layer, we have about 30 different applications that are there. Those applications range from utilizing generative AI to create automated greeting cards, to utilizing the technology to automate board meetings, for example. We have technology where we have data lakes for our IoT devices or for other organizations that want something that is more secure than on classical computers. We have encryption as a service, for example, where we have algorithms that individuals and organizations can utilize in order to secure their systems. We also have an algorithm store, for example, where we have dozens of algorithms that individuals can essentially purchase in order to optimize or speed up their particular applications. And so what we've done is we even, for example, have applications for the weather, right? Or for, watching the stock markets and the crypto markets. And so what we tried to do was we tried to take applications that were experimental and then also take applications that were everyday applications that you might see and integrate quantum into those, right? So instead of just creating like a black hole simulator or something that you might normally think of quantum being used for, we were able to integrate it into everyday applications and basically just take computationally intensive parts of regular applications code base, integrate quantum algorithms, and help to optimize and speed up the application. And so you can take quantum and you can apply it to existing applications. And since you can code in Python, you can also apply that to existing code bases and optimize your existing application without changing any hardware or changing your infrastructure or architecture.